All right, guys. So here's questions 13 to 16. All right. So questions 13 to 16 deals with exponential rules. Okay. The rules that we're going to be using are quotient rule and negative exponent rule. All right. So let's do the first example. Okay. So we see 3 parentheses u to the third power, where this 3 is on the outside of that parentheses. Okay. And then we see 5 to the u over fourth power. All right. So when you see this parentheses, guys, all right, that means that we need to be doing some type of power rule. That means we need to do some type of multiplication, all right? What you're going to be multiplying is the exponents, all right? When we don't see an exponent, all right, we can always assume that there's a 1 that represents that exponent. So this u, all right, is the same as u to the first power, okay? So what we're going to do is that because you see this 3 outside of the parentheses, we're going to multiply that 1 and the 3, okay? So we would end up having u to the third power, all right? Because 1 multiplied by 3 is 3, okay? This 3 that's in front of this parentheses is not inside. So because it's not inside of the parentheses, I'm just going to rewrite it, okay? Here, I do not see any parentheses, so I'm going to also rewrite it, okay? So now we're going to try to divide these numbers. But if you cannot divide them, you just leave it the same. Can you divide 3 by 5? No. So you're going to leave it the same, okay? Now we need to try to divide the variables, all right? So we need to do u to the third power divided by u to the fourth power, all right? Quotient rule says when you're dividing things that have the same base, here the base is x, here the base is u, all right? When they have the same base and you're dividing, you subtract the exponents, all right? So because we're dividing the same bases, we're going to subtract 3 minus 4. So I'm going to have u to the 3 minus 4, all right? So that's going to be equal to, so this 3 over 5, you're going to bring it down, all right? And we know that 3 minus 4 is negative 1. All right. So now that we have a negative exponent, we don't want negative exponents. So now we need to use negative exponent rule. All right. So this 3 over 5 that's right here, you're going to bring it down again. All right. Because it's already simplified. Okay. Anytime you're applying negative exponent rule, it means that whatever your base is, all right, when it has a negative exponent, it just becomes a fraction of itself, okay? So u to the negative 1 power is the same as 1 over u to the first power. And then the negative goes away. So again, that's how you apply negative exponent rule, okay? So similarly, if, for example, so again, this will be 1 over u, okay? Because you can't type it like this into delta, you're going to write it as 3. So again, you can multiply these, all right, and write it as 3 over 5 times u is 5u, all right, so that you can represent it on delta, okay? So again, I multiplied 3 by the 1, because again, it's the same as 1 over u, and then multiply 5 by u, we get 5u, all right? And that is the result, okay? So let's try to do the next one, okay? So we have 12p to the 6th power, all right? We don't see a parentheses, so I'm going to rewrite it the same because I do not see a parentheses, okay? Here, I do see a parentheses. I see parentheses, 3p to the 4th power, and a 3 on the outside of that parentheses, okay? So when I see that, I now think about doing power rule, all right? This p has an exponent, okay? So when I go ahead and multiply 3 by that exponent 4, 4 times 3 is p to the 12, all right? So again, we multiplied that 3 because we saw that parentheses, so it tells me power rule, okay? This 3 right here is also inside of the parentheses. So I need to multiply the exponent by this 3's exponent, all right? This 3 does have an exponent. When you don't see an exponent, you always assume that the exponent is a 1. All right? So I'm going to multiply my 3 by that 1 also. Okay? So 3 times 1 gives me 3 to the third power. So again, we multiply the 3 by the 4 right here. That's how we got the 12. And the 3 by the 1 that is technically here. And that's how we get that 3. Okay? So now we're going to go ahead and expand some numbers. Okay? So this 12p to the 6, we cannot do anything to it. But we know that 3 to the third power is a number. Okay? So this 12p to the 6, we're going to write it again. Okay? And I'm going to calculate what 3 to the third power is. All right, so I'm going to put that into my calculator. I know that in my head that 3 to the third power is 27, but you can put it in the calculator if you would like, okay? This p to the 12 is already in its simplest forms, so I'm just going to write it again, okay? So now we have our numbers and our variables all by themselves. So now we're going to try to divide these numbers. Can you divide 12 by 27? No, all right. However, you can simplify it because both 12 and 27, all right, are both divisible by 3, okay? So if I divide 12 by 3, I would get 4, all right? And if I divide 27 by 3, I would get 9, okay? What I did was simplify it. So again, I simplified this a little bit more, okay? So the p to the 6, all right, is now, so again, you can't divide 4 by 9, so you leave it the same. So now we're going to try to divide this, okay? Can you divide p to the 6 by p to the 12? Yes, because when you divide things that have the same base, you subtract exponents. So we're going to have p to the 6 minus 12, okay? So the 4 over 9, you're going to bring it down because you cannot divide it or simplify it anymore, okay? So now we're going to go ahead and subtract these numbers, and I will get p to the negative 6 power, because 6 minus 12 is negative 6, all right? However, we have a negative exponent. We don't want that. So now I need to use negative exponent rule, all right? Negative exponent rule means that this p to the negative 6 power can be rewritten as 1 over p to the 6th. So it can be written as 1 over p to the 6th. And the negative sign now goes away, okay? So this, I'm going to rewrite it as 4 over 9. But instead of p to the negative 6 power, I'm going to write it as 1 over p to the 6th. So that's going to be 1 over p to the 6th, okay? I'm going to go ahead now and multiply these, okay? So again, I'm going to go ahead and now multiply these to get a full simplified thing. 4 times 1 is 4, all right? 9 times 6p is 9p to the 6th, all right? So again, 9 times p to the 6th is 9p to the 6th power. And that is our answer, okay? So now let's do the next one, guys, all right? So up here, guys, I don't see a parentheses. So again, at the top right up here, I don't see a parentheses. So I rewrite it the same, okay? So I rewrite it the same. Down here, I do see a parentheses. But is this 4 inside of this parentheses? No. So I don't need to multiply this 3 by this exponent for this 4, okay? However, I'm going to multiply by this s's exponent. So the exponent for this s is a 1, all right? And now I'm going to apply power rule, which means I'm going to multiply these, okay? So the 4 that's in front, it's not in the parentheses, so it stays the same, okay? And when I multiply 3 times 1, I get s to the 3rd power, because 1 times 3 is 3, okay? So now we're going to try to divide the numbers or simplify them. Can you divide 3 by 4? No. Can you simplify 3 and 4? Is there a number you can divide both 3 and 4 by? No. So you're going to leave it the same because you cannot simplify it, nor can you divide it, okay? So now we're going to try to divide the variables, okay? When you divide things that have the same base, you subtract the exponents. So we're doing s to the 2nd power minus the third power, okay? So the 3 over 4, you're gonna bring it down, okay? So 2 minus 3 will give me -1, okay? But we don't want negative exponents, all right? So we need to use negative exponent rule. With negative exponent rule, it says that s to the -1 power can be rewritten as 1 over s to the first power, okay? So this is the same as 3 over 4. Instead of s to the -1, I'm going to replace it with 1 over s to the first power, all right? And then we're going to go ahead and, yep, multiply just like what we've done before, all right? 3 times 1 is 3, all right? 4 times s to the 1 is 4s to the first power, all right? So again, guys, that would be my result, okay? So again, I try to separate it so you know the difference between this question and the question before, all right? All right, so next question, all right? So at the top here, I see a parentheses, so I know I need to be using some power rule, but is this 2 that's right here inside of that parentheses? No. So because that 2 is not inside of the parentheses, I'm going to rewrite it, okay? This t to the 5th power is the only thing that's inside of the parentheses. And when you see that parentheses, you know that you're going to multiply the exponents, okay? So 5 times 3 is t to the 15th, okay? Down here, I do not see a parentheses, all right? So again, guys, because there's no parentheses, I rewrite it the same, okay? So now you're going to try to see if you can divide the numbers. Can you divide 2 by 6? No. Can you simplify 2 and 6? Yes, all right? You can divide both 2 and 6 by 2, all right? We can simplify it, okay? 2 divided by 2 is 1, all right? 6 divided by 2 is 3. Can you divide 1 by 3? No. So this is already in its simplest forms, okay? So now we're going to try to divide these, all right? So again, here we did not divide them, we simplified, okay? Here we're doing t to the 15th divided by t to the 7th power, all right? You cannot, you can divide them because they have the same base. When you divide things that have the same base, you subtract the exponents, okay? So the 1 over 3, you're going to bring it down, okay? And 15 minus 7 is 8, all right? So this would be t to the 8th power, all right? Because we don't have a negative exponent, this is my answer. I don't need to use negative exponent rule. This is my answer. So again, guys, that would be my result, all right? So good luck, guys. Try your very best, all right?